Howdy folks. Today we are going over Leetcode problem 3, longest substring without repeating characters. This is a medium difficulty challenge, so probably be a little hard. I do have a submission for this, but it was kind of crap, so I'm coming back and taking another look at it. Given a string S, find the length of the longest substring without repeating characters. Substring defines contiguous non-empty sequence of characters within a string. So if I have, for example, A, B, C, D, A, B, C, D, A, B, B, C, C, D, etc. But AD is not a substring. That is a combination. So substrings have to be, you have to be able to contiguously get them, which is important. Okay, so what we want, we're given a string. That's our input. Our output is going to be a number. That number is going to represent the length of the longest substring without repeating characters. So this is going to be the difficult part, right? Getting the substring without repeating characters. So first of all, let's just get substrings, okay? Let's just get a substring. So to do that, the quickest way, brute force, well, not quickest, but quickest to write. S.length, we loop over the whole string. I plus plus, and then we do it again. J equals I plus 1. So length j plus plus. And you might be wondering, well, why did you do j equals I plus 1? Well, because when I start out at I0, and I want j, I don't want j to be on I want j to be 1 above I. And as I advances, I want j to start 1 above I as well. Now, why did I do the j less than or equal to? Well, because if I'm going to use the substring function here. And the substring function takes two indexes, but one of them it is inclusive, the other is exclusive. So let's say I was to say substring equals, well, let's just say I was to do it like this. S.substring ij, two indices, const.log substring, and then I'm going to run this and you'll see why we do the equals. Okay, so our console, we get A, AB, ABC, ABCA, ABCAB, blah, 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 ABC, ABCB, and then we do not get ABC, ABCBB. The last character is cut off. That's because of that. Now, if I put the equals in there, you can see now I get that last character. So that's just kind of why, because I don't want to lose that last character, because a substring might be a substring that ends on that last character. Cool. So now we have our substrings. I believe enough. Oh, I can view all. There we go. Yeah. So you can see all the substrings. They slowly advance across the board. There we go. Now, how do I know if a substring has an infinite or a repeating characters? Well, let's just check the substring. All right. Let's see. J equal k equals 0. Substring dot length equals plus char equals substring of k. And then I'm going to say, okay, I'm going to keep track of my characters. Char is found equals here if not char is found k. Oops, char. Char is found char equals true. Otherwise, if we hit this else case, then we know we've found a bad one. So what I'm going to do then is I'm actually going to set a sentinel here, is okay, and then I'm going to come on here, is okay equals false. That way when I get out of this loop, and I'll break immediately. If I get out of this loop, if is okay is true, I know I never hit this case where I found bad code. So there's two common things in here. One, setting a map to something and then checking and doing something else if you find it again, right? That's how we're checking if we found our character twice. Having a sentinel value, that's what this is called. Well, technically this is not a sentinel value, but this is like a flag. We flag, I set to true by default because basically the default I want it to be true, and if something happens in here I want to set to false. Sometimes you do the opposite to that and you'll say like, oh, you know, if the default is false and something happens here I want it to be true. But in this case I'm doing it that way. So if is okay No, actually, I'm just going to grab this. So now I'm filtering down a little bit more. First, we got our substrings. Then we got our filtered substring. We filtered it and determined whether or not it's okay. It's got duplicate characters. Whoops, I don't want to submit that yet. This is not ready for submission. It doesn't work. Okay, yes, thank you. I'm aware. I just want to run it over the test cases. Okay. It still gives me everything. Oh, you know why? Because no, that should be fine. Okay, well that still kind of gives me everything, and I shouldn't be getting this one. I should be getting those three. So what I want to do then is let's at the end of this log chars found. Yeah, let's do that. Char found. Debugging. It's exciting. Sometimes it's really annoying, like with this. Okay, found A, B, that's fine. ABC. Now, when we get down to ABCA, we do get this, but our is okay. Oh, because I misspelled K. That's why. Thank you, JavaScript, for not catching that. There we go. AB, ABC, AB, etc., etc. So all the ones that have repeats are now cut out. Now we just need to find the highest one of these, right? So we need to track our highest. We're going to start off at 0, because if we never find anything, our highest is going to be 0. Okay, so now if we have an OK substring, highest equals dot max highest and substring dot length. This is just kind of a cheap way of saying, give me the biggest of these two numbers. If our substring is less than highest, then we keep highest. If it's greater, then we're going to go and switch to that one. Okay. Oh, and then I need to return highest. Okay, 3. This works. 1. This works. 3. Let's submit this and let's see if this actually works appropriately. So they gave us an error. They said, hey, we gave you this string that's really, really friggin' long. Okay, this is a long string. This is like a really big string. And you exceeded the time limit. This is too slow. This algorithm is just entirely too slow. It does not work. So this works with most things. And actually, if you provided this inside of an interview, this is not a good solution, but they might accept it and like be kind of okay with it and ask you to improve it. So let's take a look at this then. They wouldn't let us submit this, so we need to make it more efficient. Well, this is an O of n cubed solution. Pretty bad. We have O of n, we have O of n, and then this substring can also be n long. So this is an O of n cubed because we have 3 nested loops. So let's try to get rid of this third loop here. Okay? And how are we going to do that? Well, usually getting rid of a loop, we want to use a map, right? Okay. So let's see. What I could do is, rather than have get the substring, build it, and check all the stuff there, I could get each individual character, right? Because I do know those characters, and I could start adding them into a list, and then I could kind of check, and kind of, because I know what I've seen before, I could automatically know if that substring is valid, right? Kind of like how we're doing our chars found here, where we're just looping through, but let's move it out a little bit. So if I take this chars found, I'm going to put it here, and then I'm going to say char is going to be s of j. Okay, if chars found, oops, if not chars found char, I'm just actually just going to copy this. Char, and then let's move our is okay up here. We actually don't need the is okay anymore, but I'm just going to keep it around so the code changes the least. True, and then I can actually, I think, get rid of this loop. And the reason for that being, this chars found basically becomes every substring. So as I go through characters, building my substring up piece by piece, I determine whether or not I found that character. Okay, so if we already found that character, then we're not okay. If we are okay, then we could check the highest. So that has gotten rid of one of those loops. This is now an O of n squared solution. S.length. I think that'll work, yeah, because we're getting our character, we're verifying it's found. We don't need to go over the whole substring because we're kind of technically already doing that as we go over the second loop. And I'll show you what that means because that's probably a little confusing. So let's say we have A, B, C, D, A. Well, let's see, A, B, A. And I is 0 and J. That means J starts out at 1, right? Our character, we start off with a substring of A. We push A onto our map. True. Okay. The next thing we see is J goes to 2. And so now we're looking at AB. And our character is B, right? Actually, this probably needs to be J minus 1, but we'll get to that. Our character is B. So then we add B, true, onto our list. J goes to 3. Our character is A again. So our string is ABA, and our character is A, but we've already got A, so we know that string is invalid. Now, the reason I say that J can't be that, so because J of 1 is actually B. So what I kind of want to do then is I actually want to take away that plus 1. And then we're going to get some blank substrings in there because of that. Because if I is 1 and J is 1, that is a null string. That's okay. That's totally okay. Let's see. Oh, you know what? Actually, no. I don't want to do it because that's not actually okay because then we end up putting our char in the wrong place. So I'm actually going to say J minus 1 for this because that offset and that puts us down to J starts at 0, it grabs the A, it goes to 1, it gets the B, it goes to 2, it gets the A. So I'm just going to offset that by 1, even though I'm adding it here, just so that I can get appropriate characters. And I want to see if that works. Okay, it works for case 1, 2, and 3. Let's see if we submit this, if it's now fast enough to be approved by their algorithm. It is. I mean, it works, right? This is okay. This works in here. It's really, really slow, though. It beats 8% of submissions, and as far as memory, it beats 5% of submissions. It's pretty bad with the memory usage, too. Okay, but that is a solution. That does work. So if I look at my solution, this is an O of n2 solution. How would we make this O of n? Well, the way to make things O of n is we use maps to pre-compute our data, like we're doing here. We could say, okay, chars found equals this. This is pre-computing some data that we could use ahead of time. And once we've got our substring, that would work, right? So something we could do with this potentially is we'd need to probably only... Now, here's the thing about O of n. You can loop over the entire string more than once. You just can't do it in a nested loop. So if I built a map that had a list of keys that's the size of S, and I looped over those keys, as long as that loop is not inside the other loop, that's still O of n. It's 2n, but the constant drops off, so it becomes O of n. So what would that look like? So I've been thinking about this for a couple minutes, and it seems to me like what you need to do is you need to kind of pre-compute which characters are at which position, which is fine. We just have that from the string. But then you'd also kind of need to know what's ahead, like how far ahead you can look in that function. So what I'd almost want to do is, like, let's say we have our example here. Well, I'm going to do a different example. A, B, C, D, C, A. What I want to do is from A, I'd want to know exactly where the next A is. And I could say, okay, from A, right, the furthest I can go up is to position 3. So I look at A and I say, okay, that's position 3. And then if I looked at B, I would say, okay, B, it's null. There's no other position, so that's not constraining me, right? C, also null. So then I could try to go from 0 to 3, right? Let's say then maybe I had something like, well, let's grab this one as an example because I kind of like this example. It's very convoluted. Okay, so I've got A, okay, and I know the next A is at position, well, I guess it's position 3, isn't it? I know the next B is at position 4. That tells me, okay, I can't go up past position 4, but I also knew I couldn't go past position 3. Then C, I know I can't get past position 5, so that kind of tells me that. The issue is, what if your answer is at the end? So in this particular one, okay, we go P, that's null, so we have no limit. W, well, W's next position is going to be 2. So I say, okay, I could grab PW. That's the best I can do at this point. And I kind of know that the P and the W there just kind of got to get thrown away because of that W. So I'd have to keep track of where this W is because I know I got to throw away position 1 all the way up to position 1. And my kind of starting pointer has to advance to 2 at that point. So really what you need to do then is you need to keep track of where's the first time you saw this character. And then when's the last time I saw that character? And then like if I see a W here, I need to drop, my pointer needs to move up to the first time I saw that W and 1 above that. And then, yeah, so it's kind of like a moving pointer thing. I don't know if that made a lot of sense to people, but basically, yeah, the way I would handle this is like a start pointer and an end pointer. That start pointer is at 0. I'm realizing that this video is backwards on here. The start pointer is at 0, and then the end pointer kind of increments constantly. And then as soon as you get a duplicate, that start pointer, let's say I found something here, and their duplicate is here, the start pointer jumps to here and 1 above. So now I have a new substring that I'm looking at. And I can be relatively sure that substring doesn't have duplicates because I would have found them already and done that similar jump. That sounds really, really complicated, I'm going to be honest. So let's see, this is already kind of long. I think maybe I'll do a part 2 to this where I'll go over that more appropriate, like an O of n solution to see if we can figure that out. But for now, this is an O n squared solution. This is acceptable. O of n solutions are often very complicated, very annoying. And you can see it's, whoops, where is my solution? It's not a very efficient solution. This would be a much better one, and this is the one you could get if you were running in an O of n solution. So these are O of n's. But we'll see if we can get to that next time. Anyway, hope this is helpful, and I'll see you all then.